Hi everyone, my name is Matt. Thanks for joining. I'm a programming with data person at the KOF Swiss Economic Institute, and today I would like to show you how we use R and PostgreSQL to manage economic time series data. I want to do so by giving you a little James Bond start first about the three most important features of timeseriesdb, and then use the rest of the time in this little video to go into details a little bit. All right, the first thing you have to do when you want to work with timeseriesdb is to connect to the underlying PostgreSQL database. We do so by loading the R package using the package's connection functions, and we can do so interactively or in batch mode. All right, first things first, the most important feature of timeseriesdb is the ability to store time series consistently over a long period of time. When you work in official statistics, you face a lot of spreadsheets. And if you want to store time series in spreadsheets, it's really difficult to keep their identifiers unique within or even across spreadsheets. And also another problem is if you want to manage versions, you end up with a lot of files named like final version, final version, and then people eventually start to put their names into file names, and then things get even messier. And of course, as a data person, you don't want none of that. You want to avoid that. And timeseriesdb gives you a chance to do so. So in this little R example, you can learn how to store time series using timeseriesdb. We load the package, and then here we create a little list that contains two random time series. And we store the list, the entire list, to the database, and the names of the elements of that list become the keys later on. The advantage over file-based storage is clearly that the database is going to enforce that these keys, the identifiers, are unique. But it doesn't stop at enforcing unique keys. There's a lot of other constraints that the database can easily enforce. For example, think of access management. If you want to have it very granular, it's pretty easy to implement in a database as opposed to a file-based system. The second feature that especially forecasters like is the ability to keep track of different versions of time series. And here's a little example from the KOF tourism forecast. As you can see by the highlighted line, there is a validity parameter passed on. And this makes the database go to the time series that was valid at that point in time, which was before the most recent publication of the KOF tourism forecast. So if I leave this parameter out, by default, the database just gets the most recent time series, in this case, overnight stays in Switzerland. And as we can see, in the previous forecast, we thought, okay, this is gonna take a hit and then eventually gonna rebound pretty quickly. And now we had to adjust this, revise the forecast, and now we think, okay, it's going to go down a little further and then hopefully rebound back quickly somewhere next year. So this ability is something that forecasters clearly cherish a lot. All right, the third feature is a feature that's particularly nice to have in Switzerland, where we have three major official languages, plus you want to have everything in English. We can have meta information very comprehensively and in multilingual fashion. Our functions just accept keys to refer to the time series, and then there's a locale parameter, so you can have German data or French data, and of course English data as well, and whatever other languages around. All right, these were my three features. So time to take a little step back and look at how things are implemented and how all of this works. All right, first of all, there's R and the elephant in the room, PostgreSQL involved. And Postgres is, of course, a relational database. And with a relational database, you have some tables. You map things to multiple relations. And I'm not going to talk about all these tables in detail, but we have tables for the data. We have tables to manage the releases. we have tables to manage the data description, and there are a couple of other tables for a couple of other features. But what's also noteworthy to mention is this little line right there. The data, the time series itself gets stored in a single cell, in a JSON cell. And that's something we did when we tailored this system to official statistics. When you look at time series DBs on the internet, most of them come from the Internet of Things world. This is where the money is at. And all these databases can do append very, very quickly. But what they cannot really do well is update and handle revised data. Because, I mean, who updates log files? Who revises log files? And also, these databases implement window functions at the database level. We don't do that because when we don't do it, we have the ability to keep things lightweight, a lot more lightweight than these databases. And even with a large catalog, we can stay pretty slim infrastructure-wise because of that. And usually economists don't need window functions at the database level. We get the entire database, the entire time series out of the database, and then process that in R, in Python, in Excel, in whatever program we use. So we are really making the database tailored to that use case. All right, the second fundamental thing is, again, the elephant in the middle, and we put a security definer around it. What that means is the SQL function that most of you know probably, like the select, the insert, we revoke all of these functions, the rights to execute them, this functionality from the ordinary user. If you're not an admin user, you cannot do it. And we create functions, and these functions are executed not with the right of the user that executes them, but with the right of the definer. And that way you can do all sorts of cool things with these functions, but you're limited to these functions, which keeps things secure. And more importantly, it allows multiple clients to connect with very thin layers on the client side, because the logic is in a database. So our SQL people, they can just use their PostgreSQL client and use that. Then for this talk, the focus is on the R package that queries data from the database. And we could also use other technology, but R, for example, some web technology to add a REST API and then expose the data online, show a time series on the internet, right? But let's leave it at that and go to an R perspective, see a more applied approach about the R functions grouped in at different levels. So there's time series level. There's a few time series functions, db, ts, underscore something, you read and store, straightforward. Then there's a find function where you can use regular expressions to find certain keys. And there's another example of a TS level function is the read history function. You can get all versions of a single time series just by using the read history function. In this case, we use the economic barometer. And then we see, okay, there are quite a few vintages, namely 73 vintages in that database, and we can then simply access all of these vintages in the list that were returned by the function. Then, as you can see, this neat little syntax goes on. We have DB, and then there's the data set level. So imagine using that when you use RStudio or whatever editor with an autocomplete feature you have, and then that's it will eventually show all the functions at the level you are currently operating. And data set level is, well, that's to group data sets. Every time series in time series DB has to be part of a data set. If you don't specify a data set, it's going to be added to the catch-all default data set. But that way, we can have meta descriptions at data set level as well, and also release descriptions at the data set level, which is very handy for a description that fits a lot of series. A similar concept, but another use case, is the concept of collections. Collections are individual sets, and yeah, that's, for example, if you are an expert on retail trade and you have to go back to the time series every month, again, every time they're released, you're looking at them. So you don't want to compose your set of time series all the time again. So you specify a collection, give it a little name, add all the keys that you want in there, and then a description that helps you and your colleagues to find that series again. And the entire thing is user specific. Think of it like playlists in a music player. All right, and then there is access management. That's also very flexible, but also very easy. You can just specify an arbitrary number of access levels, and then add these access levels at the time series level. You can change access levels of time series later on. And in Postgres, it's just role level security. And you have just to add a role for the access level, and then by adding it to the time series, it's already implemented. All right. Then there is functions for meta descriptions, and we've already seen that. So what I would want to mention here, you got the possibility to have meta description at the time series level. You can have it at the version level and at the dataset level, and all of it can be multilingual. If that was a little too fast, and you want to read things at your own pace, you can just check out our GitHub documentation. It's a package down documentation. There are articles on basic usage, on developer documentation, but also there's a neat little installation guide. All right, and this is where I want to dwell for a little bit. How to get started, and let me try to lower the hurdle a little bit to try things out. If you know about Postgres, if Postgres is already installed, basically you got home court advantage. It's really easy. I suggest you create a separate schema, then you install the Postgres extension mentioned here if you haven't done so far, and then create schema admins. You can follow this little installation guide right here. It's really easy to follow. You can use features of package down, like copy pasting all these code chunks if need be, and then installation will be very easy. On the R side, things are even easier because we got a wizard, and wizards do what wizards do. They do magic in a black box. That's our little installation functions. You pass on the connection parameter and the schema, and you're done. If you are not familiar with Postgres, there's another option. We ship timeseriesdb with a shell script to launch a Docker container. So if you've got a Docker environment installed, you can just use this. Beware that we are not using, in this little example, a file mount. So if you kill the container, if the container is gone, the data will be gone. But you can work past that if you just add the -v parameter and mount some folder of the host operating system to keep the data when you shut down the container. All right. So if you have Docker Desktop running, Docker or another Docker host, and don't really know about databases, an easy way to get started and to try out and feel things. All right, I'm almost done. So let me summarize for you why you should give timeseriesdb a shot. It's really easy to try out. We try to lower the hurdle even for non-database people to give it a shot. You can really grow into it. You don't have to use all the features. Many of my colleagues just use read and store and start with vintages a little bit, and it's, yeah, they already benefit from the tool. Then the entire thing is really tailored to economic statistics. It's in use since 2012, and we're constantly developing it. And yeah, it's really tailored for use in official statistics. Then it's lightweight and it's license cost free, which kind of doesn't make it a vendor lock-in. It's easy to move away if you wanted to at some point. Documentation, we put a lot of effort into documentation. It's easy to understand. There's context level information. There is the package downside, lots of information on how to get started. And then last but not least, it's API ready, and a lot of the logic is language agnostic. That means you can, by using very thin layers, also use timeseriesdb in other languages. And that's also the example I want to show on the way out. That's the example of the REST web service of COF, which is also backing on timeseriesdb. And as you can see, this is the COF website for the economic barometer. And this little graph right here is interactive. And the moment we update the database, this graph gets updated without anybody interacting with the content management system. And the same holds for these little links here. These Excel spreadsheets that you can download don't exist physically. Yeah. So that's that for me. And if you're interested in following through, here are the resources. There's a documentation development site and CRAN, but note on CRAN is not up to date. So please use the GitHub version if you want to check out the feature of this talk. And as always, feedback is really, really welcome. Use the issue tracker on GitHub or hit me on Twitter. Yeah. Thanks a lot for your attention. Thanks a lot for listening. Continue to enjoy Euros and have a nice day.